Ooh, yeah, this is the exact opposite of what I wanted. Hey, it's Pete. Welcome to the workshop. I've been revisiting my shop storage lately. This shop is actually very small, and if I don't keep on top of it, it gets unorganized very quickly. Any flat surface begins to collect clutter. This video is both a sequel and conclusion to two previous videos. Back in March of this year, I showed how I had designed and 3D printed bins to insert into the Harbor Freight storage cases. At that time, I had a lot of requests for the 3D models, but I hesitated to release them because I knew there were errors in the drawings. At that time, my 3D printer wasn't calibrated properly, so it wasn't printing things at the proper size. And rather than take the time to tune the printer, I corrected for it in the model. Not the correct way to fix the problem, but it got me up and running the fastest. So I finally got around to modifying these drawings to make them technically correct, and while I was at it, I added a few additional sizes to the collection. Starting with the 3 original bin sizes, I created additional sizes by simply multiplying the dimensions of the smallest size bin. As I discovered in the previous video, you can make bins of almost any dimension you like as long as you base the dimensions off a multiple of the smallest size bin. All of these bin sizes are created by simply multiplying the shortest side of the next smallest bin. I also included 3 sizes that were multiples of the long side of the smallest bin. My primary design consideration here was that all of the bins had to fit within the print surface of the Ender 3 printer, so none of the bins exceed that size. Stick around towards the end of the video and I will tell you where you can download these models. Speaking of Ender 3, up until now I've done all of my printing on a heavily modified Creality Ender 3. I believe I mentioned before that I removed all of the electronics from the base, extended the wiring, and created an enclosure around the printer using an IKEA table and some 3D printed leg extensions. With a bit of insulation, this gives me the ability to reliably print ABS parts. ABS prints at a higher temperature and is very susceptible to warping due to drafts. For part of this project, I wanted to use a particular color that I could only find available in PLA filament. Now, PLA can print at room temperature with no special considerations. So rather than tie up my ABS printer, I decided to add another printer to the fleet. Are 2 printers considered a fleet? They're not a farm. I purchased this printer about a year ago when there was a sale I couldn't pass up, but it's set in its box until now. The printer is well packaged and assembly is fairly straightforward with all the required tools provided, although they are of dubious quality. As far as printers go, this one requires a bit more assembly than some of the other ones on the market, but that also contributes to its lower price point. And besides, I'm a tinkerer at heart. Assembling stuff like this, at least for me, is sometimes more enjoyable than actually using the finished product. If you haven't added 3D printing to your workshop tool arsenal, it may be time to start considering it. Now, it's true there are a lot of pointless and ridiculous things that you can download from the internet to print, but I've primarily used mine for practical purposes here in the workshop, printing fixtures and organization systems, and even a few short-run production items that I was selling. Printing has come a long way since I first started looking at it 10 years ago. You might want to consider adding one to your Christmas wish list. I will warn you though, these are not appliances or even tools. These are projects in their own right. You will find yourself constantly upgrading and tweaking their performance, and buying different colors of filament can become its own addiction. That warning aside, I have included a link below to this particular printer. Besides allowing you to print basically any size bin you might need, you can print them in any color for either aesthetic or organizational purposes. I now have a complete range of bins that should satisfy most of my small part storage requirements. The next area that I wanted to address was a follow-up to a project where I had created a storage rack for my Ryobi cordless tools. At the end of that project, I was left with the task of creating some means of storage for the accessories that go along with those tools, the bits and blades and other consumables I have. In the interest of consistency, I decided that my Harbor Freight cases would be a good solution here as well. I could use my extended collection of bins to store items, and where appropriate, I could design custom inserts. I searched and found the closest match I could for the Ryobi Green. This is a filament by Filicube called Greenery, and it needs just a little bit more yellow to be a perfect match. I first tackled this project by designing a bin that would hold all of my driver bits. I started with the original Harbor Freight large bin dimensions and created a tray with 1/4-inch hexagonal shaped holes. Since there's nothing to hold the bits in place besides a slight amount of friction, I set the tray height so that the lid of the case would prevent the bits from falling out. Then rather than wasting all the space under the driver bits, I split that bin into an upper and lower tray. This gave me an area for general purpose storage, a place to store some of the longer driver bits that I have. Next up was something to hold the T-shank jigsaw blades. Here again I went with a stacked tray approach. I created a bottom tray with feet that would fit into the base of the Harbor Freight case, and then thinner trays to stack on top. So I noticed a little problem when I took these pieces off the bed of the 3D printer, that they had a slight warp to them. What I want to try to do here is a little bit of an experiment. I have this toaster oven which has been heavily modified. Normally I use this for reflowing printed circuit boards. However, it also has a function for baking where you can set it at a very controlled temperature for an extended period of time. So what I'm going to do is set this oven to be basically the same temperature as the bed of the 3D printer. I don't want to melt the parts. I just want to soften them up a little bit, that I might be able to go in there and just coax them back into being flat. All right, let's take a quick peek at these and see what we got going on. Ooh, yeah, this is the exact opposite of what I wanted. All right, back to the drawing board. Well, I managed to recover from our warped parts. Unfortunately, one of the things I forgot was the concept of annealing, and that's where you heat a plastic part up to its glass transition temperature, and just like annealing of metal where you're trying to remove the brittleness, this causes for a stronger plastic part, as well as helps to reduce the tendency for the layers to separate. It's a great process. Unfortunately, in the process, the part also shrinks slightly, and that's exactly what's happened here. These are much smaller now than they originally were. I printed a new piece, and as you can see here, this is actually fairly substantially shorter than it originally was. So much so that the jigsaw blades no longer properly fit into their openings, and the piece itself no longer properly fits into the tray. So this is a failure here. We're going to have to go back and start over, which we've already done here, and we'll continue on from there. All of these trays include 3mm magnets glued in place to help keep the blades in place and keep the trays stacked. The thing to keep in mind when gluing the magnets in place is to keep track of the polarity. You want to install them so they attract and not repel each other. Don't even ask me why I'm telling you this. Another tool in my Ryobi collection is the laminate trimming router. I have a small collection of bits that work with this tool. Again, I created a 2-tray approach to hold the bits, and again, magnets are added to help hold them in place. Here I used 6mm magnets for the shafts and 3mm magnets for the corners of the trays. I also created a block to hold drill bits. This block has a special little trick to it. After printing about 2mm of the base, I paused the print to glue a 32mm magnet into a hole before continuing the print. This helps to keep all the bits in place. This is just a block sized to fit inside one of the custom bins. In this case, the bin that I call small X3. I filled out the rest of the Harbor Freight case with various size bins to hold consumables like brads and other tool accessories. So I'm going to release all of these models for download on my website. It's going to be a single zip file that contains all these custom sizes. It's going to contain the Ryobi accessory holders, as well as the Craig jig holder that I had shown in a previous video. All in one zip file, and you can download it at the link below in the video description. Don't forget to take time to tinker, and if you'd like to catch another great project, click that link to the left and I will see you over there.